And then let me go to the chat. So I'm in the lab today. And the goal is to go over some relay logic, test it a little bit. Let me know if you guys get an attachment in the chat.
I did.
Okay, perfect. Let's see here. So, let me share my screen. All right. So you guys.
I'm sorry, Leo.
Yeah.
I can't open it because it's shared through. I think it's because it's shared through an external SharePoint site.
Oh, okay. Wonder if I can email it. Well, that's annoying.
You might be able to just download it to your desktop and drag and drop it in there too, so it doesn't come straight from SharePoint. Not sure though.
Well, I did grab it from my desktop.
Oh, okay. I don't know. That might be a linker.
Huh. Okay. And were you trying to open it or trying to download it?
I was just trying to open it.
Okay. Try. You can see my screen. Try the download. See what happens. I'm just trying to get you guys you guys can look at the logic on one screen, and I can share the visual of the front of the relay on the other.
I'm not sure I have that option, Leo. I'm sorry. I'm
Hey, how's it going?
feel literate in this.
All right. Let's see. Maybe I can email it to one of you guys, and then you guys can forward it along. If I go to people,
Is anybody else having difficulty? If it's just me,
I was able to download it locally and then open it as a PDF.
Are you on your ECI Teams, Shane?
Yes.
Okay. Yeah, it's
Everyone engage.
Okay. Go to my email. See if I can send that along. I think this will. Does this tell me who I sent it to? Who he sent it to? Well, I guess that's annoying. Okay. Well, didn't know that was going to happen. Okay. So let me know if you guys can see my screen. I think you're in person, so you get your very cool. All right. All right. Well, the goal is to run through this logic that I have here. I've got this logic, or I'm about to push the settings for this logic to the 421 that we have in the lab here. So yeah, I'm gonna push it to that relay there. And the goal is really just to go through the logic diagram. You know, we're gonna be pushing the push buttons on the relay, driving the different lockouts and control switches on the front of the panel here, and you know, just to highlight as we go and verify that everything works as it's supposed to. You know, it's just a good opportunity to maybe get away from the math and the stuff like that that's scattered throughout the lectures, and you know, put our hands on something and um, yeah, just do more than that. So I'm gonna go back to sharing screen here. So I've got the settings here. I'm gonna push these to the device because it looks like somebody has overwritten my settings at one point or another. So I'm going to send these settings I have here. Oh, so that's me. Looks like it's still thinking about it. Okay, it's establishing the connection. I guess you can't see it, but I'm plugged into the Ethernet on the back of the device. Okay. I was just connected right before we started talking. Weird. Yeah, no, you can look at this version if you want. What the heck? Parameters. Yeah, 192.168.1.34. Here. Right, for, that's B. Look at there. Yeah. 14. Doesn't seem to be doing much though. Well, what the hell? This was literally working right before you guys came in. All right, I guess we'll try that other 421. Yeah, I guess. I was like literally just talking to it before you guys walked in. You know, that doesn't seem to be a great connection on my computer. Yes. I'm gonna pull that yellow out and plug this one in that same spot. See if it likes that. If not, we'll go to that one. All right. Oh, yeah. Oh, looks like it was a bad cord. All right then. Let's try sending those settings. Or no, I guess.
Yeah, right.
Okay. So we're gonna send them all. We don't care about sets 2, 3, 4, 5, 6. We definitely don't want to send any port settings. We only care about protection 1. Don't care about DMP or notes. All right. Send those over. While that's pushing, we can run through some of this logic. Um, so this is a pretty typical logic diagram that you would work with. A relay settings job. On the left side here, you've got the relay inputs. Those could be hardwired inputs. Those could be the push buttons on the front of the device. SCADA points, any information coming into the relay. I think in that first lecture, I may have had kind of a table of some typical ones. Off to the right, you have the outputs, right? Information leaving the relay. Looks like here we've got some LEDs. You can see them on there. But those could be hardwired outputs, like we see here, that actually drive a set of physical contacts on the back of the device. Those could be points going out of the relay to SCADA. Section messages that can be sent either over Goose or mirrored bits or other protocols. And then in the middle, you've got the logic. This is what we, are programming into the relay. And it's going to make me wait a second before I can show you where that's happening. But you can see here, we've got different things, right? You push a push button as long as you hold it down for 60 cycles, 1 second. It's going to send this rising edge trigger. You guys remember that from a homework assignment. And as long as that control is disabled, right, we've got a NOT gate, it will enable it. Next time we push that push button, it's enabled. We're going to have that AND gate. It will disable it, right? You got your set and your reset on that latch. So basically what this set of logic right here does is it allows us to turn that function on and off. We can toggle that function through the push button on the front of the relay. So like I said, our goal for this lecture, run through all of these different things and prove that they work. What we have here is a lot of your on-offs. But we get into more stuff. We can open the breaker, close the breaker. We got some test trips. We got some test reclosing that we can run through. A few good functions. So got my handy dandy highlighter. I'll be highlighting local copy here as we go. We'll try to think of a good way to send this. Actually, we'll try this. Does everybody in this chat, do you mind pasting an email that I can send this PDF to the chat, and I'll get you this logic diagram so you can look at what's going on live here, but also have that logic diagram. You can just type yours in if you want. Yeah. I don't know if you're getting your laptop out to send it to me. All right, we got 3. I'll give another minute or 2 if anyone else wants to be able to look at this PDF as they work. Hey, you can just come type yours in. All right. All right, it's everyone. Now that you guys, I guess, have that, I'm going to take my focus off of this, put it on the actual camera, and I'll be working with a local version. You guys should have your version on your computer, and you guys should be able to see the front of this relay. Ready? Oh, thank you. All right. So hopefully that's a good view. We're working with this relay right here. You guys probably have a tough time reading that text. Let's see if I can get this just a little bit. All right. There we go. Hopefully that helps a little bit. So we'll start with the beginning of this logic here. It looks like maybe the first thing on here is the push button for 52 control switch of the breaker or the relay. So what we've got on here is we've got a push button for breaker closed and breaker open. Right now we can see that the breaker is closed. It lines up down here with the control switch for breaker closed. We can see right that shows closed. So basically what this logic does is it changes our permissions to open and close that breaker. When I put this in 52 control switch enabled, that means I can open and close this breaker from the control switch down here. When it's in relay, that means I push this push button up here. So right now it looks like it's in relay. So with it in relay, doesn't do nothing, right? But I put it into 52 control, right? I had to hold that for a full second. I can turn this on and off. That toggle. Well, with that, we've just verified that logic, right? We're able to toggle it on and off. We can come in here, say, okay, that worked. Now with that, all right, I'll put it on 52 control switch. Now you can open and close it from the control switch. See the status changes right there. Take that off. Doesn't do anything. But now that control is enabled through our relay. We can close, open, close, open. So if you guys don't mind following along to, let's say, sheet 3, we can see right here, if we push button 7 for 1 full second, and the breaker's open, right? It's no point in closing a breaker unless it's already open. We push the push button for 1 full second, and the breaker is open, and we're not being tagged hold. That's another function we'll get to. And we're not in control switch mode, we're in relay mode, then it will close the relay. It comes to the internal closing logic. This is all internal. That'll get processed and then, go to that output over here, which is what's actually, wired.
So there's a diagram like the relay comes, just like with internal bits.
Yeah, yeah, this is what's going on inside of the relay. Everything here is what we can program. And then this dotted line, that's what's called internal logic. That you gotta go to the instruction manual, and it's, the manufacturer has provided some functions that you can interact with.
Oh, cool.
So, but we'll roll through this. I won't highlight any of that other logic, but I do want to talk about some of the other functions that played into it. So, next one that we have here is a test mode. It's a very similar toggle. What happens here is, again, you push the push button. The only difference of this one is when you're in test mode, that LED is going to flash because it's got this flasher right here. That's just logic that feeds into itself, and it turns itself on and then it turns itself off kind of automatically.
Cool.
The relay's got a test function. If you want to do any test trips, everything that we're really doing is testing, right? This isn't in a real life scenario. There's no voltages occurring, so we're testing. So this is a test mode, right? Same thing. You got your test mode on. You can see it's blinking. You can turn it off. So we verified that worked the way we wanted to, right? We push button 4. It blinked when we turned it on. No, it didn't blink when we turned it off. All right.
So what's like behind like these bits right here? What is this block?
That's a latch.
Latch?
Yep. So you can see here, you see how you have an S and an R. S stands for set, R stands for reset.
Okay.
So when you have a 1 come into the set, actually it's just going to latch. So you can give it just a quick pulse and it'll remember that. And it'll stay that way until you reset it.
Okay, so when you hold it again for like a second, it comes to this side and it resets it like there?
Yeah.
Cool.
Yeah. Yeah. And yeah, it's because of that knock gate, right? If let's say that was off and that was a 0, well, you have a 0 right here. Come around, you have a 0 going through a knock gate, that's a 1. And then you have this signal come in. Well, a 1 and a 1 going through an AND gate will set it.
Okay.
And then once it's set, now you have a 1 over here. Well, coming back this way, a 1 going to a knock gate is a 0, so we can't set it anymore. But a 1 with a 1 resets it. Yeah, little toggle. If you want to get real clever, try and wrap your head around that one. It's so simple, but So the next one is a pretty common function. It's called breaker hold. And the goal of a breaker hold is you've got people on site and we don't want to be opening and closing this breaker for safety reasons. So with breaker hold, you can't open or close the breaker. Right? We want to keep these people safe. It's kind of built into some places into like a switching and tagging, scheme. Kind of like a lockout tag out, if you would.
Okay.
So you would put it in hold. No one can open or close the breaker. And for safety reasons. So this is just the toggle for the enable. Looks like that's push button 5, breaker hold. Turn that on. Get into what happened there. I'll turn that back on. Okay. So that one seems like it worked. So this sheet of logic, looks like we're pretty good on. Let me check, make sure, does anyone have any questions? I know we've probably got a lot going on here between, I guess just me talking, the relay, and you're looking at those PDFs. I guess I am curious, are those labels, can you read them? Are they backwards? Maybe you guys have anything to say about those?
It's a
I'm
little
having a hard
hard to
time
see
reading them.
them, but
Yeah, I can see those might be a little hard to read.
I don't think they're backwards though.
No, they're just challenging to read.
Almost there. Yeah, I
probably
mean,
look
test
pretty
trip.
silly.
Okay,
You guys
we can
see-
start seeing them. At least the push buttons. Seeing,
Okay.
yeah, we can read it.
Okay,
Pretty
we're
well
getting
now.
better.
Yes, not the LCD screen, but the labels are visible.
Oh, you can read them if you don't follow your subconscious anyway. Okay. So, we're gonna move to sheet 2. So a lot of these that we got going on, these are protection functions right here, in the trip equation. Oh, let's see what that Teams message was. Yeah, you guys should have that software. Yes. You should have it. That was a assignment to install it. But I can actually send you this file. If you guys want that, you can open it with that software.
It's just the accelerator quick set, right?
Yeah, yep. But yeah, you guys can open this also. It's right here. You guys will see at the top here when you try and open it. This is SCL 421 Rack 2. I haven't spent a lot of time in here. I know we went over it kind of in those first couple weeks a little bit, but this is the programming. This right here, right? Kind of tough to follow along with everything that's going on here. It's a lot of text-based programming. This is meant to be a visual representation of that programming, essentially. It's definitely a lot easier to follow. I've gotten so close that it's hard for me to actually squeeze in here. I guess someone, if you are able to open up that programming, let me know, and or if you're not able to, let me know also.
Hey, Leo, I guess I did not put my email in the chat since I thought it was just for that logic, which I was able to open.
Oh,
Could you also send it to me?
yeah, I'll send it to you. Okay.
Thank you.
Yeah. Okay. So, okay. So we're on sheet 2 here. And what we'll try and do is verify this trip logic. So I'm going to try and really verify right now everything that comes in here. So that word bit is called DK1, breaker 1, MTR, manual trip. So we're going to manually trip that breaker. And we're going to go through the processes that we just did. So we can see here, we push button 8 for a full second. Right? Breaker is closed because no point in opening a breaker if it's not closed. And we're not in hold. Right? We got that safety function. And it's not in control switch mode, then we'll close that breaker. The flip-flop down here, everything is the same except we are in control switch mode. So it should do the same thing. So we'll run through this. Right now, the breaker is open. We're in relay mode. Let's close it. Second, to this breaker is closed. All right, we can see right there, breaker's closed. Okay, so that part of the logic is good. We're not in hold, okay, and the control switch is not enabled. We should be able to push the push button for a full second, have it come through here, hit the breaker 1 manual trip, and have that go through this internal logic, that output, which will actually open the breaker. Okay. All right, that. So I'm just going to highlight this portion right here. We're going to do the same thing. All of that logic is the same, except this time we have to be in 52 control switch, and we are going to use the control switch open command. You can see right here, that control switch down there, it's going to have a contact associated with it. When you do that close signal, it's going to close a set of contacts. That set of contacts is wired to the relay. It's going to see that as an input and drive this logic. So we'll put it in control switch mode. Then down here. So now.
That wasn't a control switch? That wouldn't work.
No. Take that off. I'm doing it. Put it in control switch mode. Yeah, and same thing, we can come in here, right? It's working great. See that hold function? Right, we hold, we can't open or close it. Doesn't matter if we're in this or not, right? It's hold, we're not do anything. So we've also tested that function there, the hold function.
Nice.
So, yeah, turn that off. They're closed right now. Looks like we can verify all of that. And then some other logic on here. Right, that's the LED that we talked about, right? We can see, you know, we close the breaker, the LED itself turns. Oh. So we can see the programming for that LED is also good. And then we can see there on sheet 3. That's also good. So some troubleshooting tips on this. I'll share my screen. So right now we're just visually looking at everything on the display. But what you can also do is you can come in here, and if you go to tools, or no, if you go to this right here, this is that terminal. we can actually see what's been asserted. Should be able to see what's asserting, unless I lost communications, which is very possible. Through me moving my computer all around.
When you were like pushing the buttons for breaker opening and closed,
Yeah.
was the sound like the actual contact in the like switch down there, like opening and closing? Is that what that is?
Yeah, it was actually, if you want to come stand right there. What? You see that middle one right there?
Yeah.
Watch, I'll press that button.
Okay.
So this is kind of meant to simulate that breaker. It's actually this thing opening and closing. Cool. Yeah. Yeah, that's the sound. I don't know how the hell I lost communications again. I was literally, you guys saw me, right? I was communicating. Weird. Okay. I was gonna show you the SCR function. But if I can't communicate, I guess I can't. I'll give one more college try. Okay, I guess it'll work if I do it like that. I honestly don't know if it's my computer or if it's the relay. I think it's the relay. I think I had issues with this COM port last time. All right, yeah, no more communicating. Let's go back to seeing the front of the relay. Okay. So, we made it through this logic here. Probably just going to leave this logic for a little while. There's portions of this that we really need a test set for. Right, these are all overcurrent based elements. We would need to simulate, currents that you would see, on the actual grid. In the real world, right, you've got your CTs, they bring the current down, they bring them to the back of a relay. If you are in a testing environment, you can get what's called a test set. Oh, that one. You can wire up a test set and actually currents to get these overcurrents. We're not going to do that today. We do test trips to see though. So that stuff, right? That would all be stuff you push with a test set. That's all stuff you would push with a test set. That's all stuff you push with a test set. So we can do a lot of stuff. Oh, and that output actually drives. You see that little light that's on down there? That's the contact in the, in the string that turns the light on. Okay. Yeah. All right. So we just worked our way through a lot of sheet 2. We'll get into sheet 3. And we'll come back to sheet 2. But for right now, we'll move past it. So on sheet 3, we have some reclosing logic. The first part of it, we call it a 79 on. 79 is the answer number for reclosing. So most faults are temporary in nature. Right, the squirrel climbs onto a line, burns, and falls to the ground. In that situation, you can trip because you need to clear it, and then reclose maybe 5-10 seconds later, and you can successfully reclose. So this here's the function to turn that on and off. Maybe you don't want to automatically reclose. Maybe you got people working out on the line. And you don't want to reclose it on them if they were the person to inadvertently cause a fault. So this is
He's gone for you guys too, right? Okay.
The logic would have been useful for the exam. That all the
Yeah.
input.
How'd you guys feel about that?
Woo. Not too good. I mean, just a bit of a time crunch for that RDB file. Like, yeah, 2 through 5 were good, but that first one,
Yeah.
did all right with the logic.
I didn't feel great about it just because I didn't fully
Yeah.
understand what he wanted. So it was like, does he literally just want me to do that stuff that he described, or like,
That's what I did. Yeah,
like, I don't know.
we'll see. Yep.
That's what I did. I added the caveat, like I think you'd have to manipulate a lot of other things in order to override, but who knows?
Head scratcher for sure.
Yeah. Pushing us right in the deep end.
Yeah, I ended up emailing him, asking if he would consider a bonus assignment after 5 here.
Yeah.
We'll see. We'll see what he says.
Yeah, I think I must have spent, I'd be willing to bet 8 to 10 hours on that first question. Just that question. Everything
Mhm.
else was relatively straightforward. I hope.
Yes. Yeah, all the other ones were nice. We'll see.
Hey guys, sorry about that. My
Hey.
looks like my battery ran dry. I got to plug back in.
Yeah, no problem.
All right, let me get back to Teams. Yeah, my computer is mad about it. We'll keep going with the camera here. Alrighty. So yeah, we're back. We can see the front of the relay there. If you guys can see what I'm working with, I've got my computer literally right up against the rack. It's a little unfortunate. You know, you guys can't see the control switches very well. You also can't see, you know, we've been highlighting the logic here in person. So that's kind of the goal that we've been going through. Sorry, with the positioning of my laptop, I didn't realize that we were right up against, you know, I didn't realize that my computer had died. And now, I don't know what the deal is with it. Computer's struggling. I got my phone though. So now we're gonna go over to this logic here. This might actually even be better as far as being able to see the logic and then the relay. So now what we're gonna do is we're gonna work through some of this test logic. So we talked about that test mode before. We can see here, we've got something called a porthole, rat hole, to, from, reference. People call them different things. That's for the test mode on. Right, we can see it comes from sheet 1. Right, just like we see here, right? Test mode logic from sheet 1 goes to sheet 2. Should probably mark that up because it looks like it also goes to sheet 4. Yeah, there's your test mode logic. So we see it here, right? If I push button 3 and we're in test mode, we'll have this test trip. You guys should be able to follow along. And that'll go to the actual trip logic on sheet 2. Which if you guys have the PDF right there, you can look right over there, right? You should see the test trip coming in. It'll hit the trip equation. The trip will then go to the output, and then we'll have an indication on the front of the relay here. So right now, breaker's closed. All right, we can see the breaker's closed. Why don't I put it in test mode? You can see that blinking. And then in test mode, I'm going to give it a test trip. Okay. With that test trip, we can see here our LED for test trip latched in, letting us know that that trip was in fact a test. And we can also see this test LED right at the top here, that latched in. You can see the breaker opened, and you can see it here on that LED, but you can also see it down here on the control switch. Okay. It likes this better now. It won't let me join. All right. Alrighty, I think I got this. Sorry, I'm kind of running my phone and my computer at the same time now. So we can highlight a bunch of this logic. Can you guys still see the picture from my phone?
Yes,
Yep. Okay.
it
Cool.
is.
Yeah.
Pretty pixelated.
Is it? Yeah, I don't think the
Yes.
Wi-Fi is great down here.
Yes, but we can figure out where to reference on ours.
Okay, so that might even be a bit better. It's just verbally tell you guys. So all the way to the left on sheet 4, we pushed push button 3. We held it down for more than a second. Test mode was on. We're going to make it through that AND gate. We hit that test trip. It comes over here. We hit that latch, right? That latch went to the push button 3 LED. That's just still illuminated, right? That latch. Until I hit the target reset. Once I hit that target reset, that will reset and that'll go away. But also on sheet 2, we could see we had our test trip come in. It hit our trip equation, which is actually going to drive that little LED up there that lets you know you hit the trip equation. Went to this right here, and then went to that output, tripped the breaker, which we saw.
Yep.
And then what I should be able to do is now over here, hit this target reset. It'll make that LED go off. And then you'd really have to look in that internal logic and instruction manual, but it'll also make that LED come off. So there's your target reset. And we can see we're still in test mode. Our test trip went away. And, that trip LED went away. Turn it off, test mode if we want. When we turn it off test trip, that test trip shouldn't. When we turn it off test mode, that test trip shouldn't do anything. Which helps us feel better about that, that part of the logic right there. So yeah, we can highlight a bunch of that. By that output because we saw that roll. So the next part of this, we have a test breaker failure function. And we haven't spent a lot of time on breaker failure. But what breaker failure is when you tell a breaker, we need to trip. There was a protection function, a fault on a line, we need to trip that breaker. Breakers are mechanical devices in nature. They're supposed to always work. They don't always work. And when they don't work, we call that breaker failure. And if a breaker fails, the goal really is you need to say, this breaker didn't work. I trip all the one around it, all the breakers around it will get rid of that fault. So usually the way that we can tell if we have breaker failure is, we'll send that trip command. We know that it might be a 3-cycle breaker. It's supposed to clear that fault in 3 cycles. Well, if it doesn't, and let's say 10, we give it a little bit of a margin, then we know we've got a bad breaker. We need to trip the other breakers in the area. So on sheet 4, you can see we've got this test breaker failure logic down here on the bottom, which is driven by push button 2. You can also see up above, we've got some actual breaker failure logic. We'll get into that. There's 2 types of breaker failure. There's a current-based breaker failure, which just means that that current better go to 0, right? We tripped that breaker, current should go to 0. If it doesn't, then we can declare a breaker failure situation. So that's called a current-based breaker failure, right? We can't really use that because we don't have a test set up. If we did, it would test it. And then we've got another thing called no current breaker failure. Let's say we trip for something that's not related to current. Let's say it's voltage or frequency. In that situation, right, current's not going to help us. We got to pick another operating quantity. A very typical thing to base it off of is the breaker status itself. So we've been seeing this whole time when we trip the breaker, we get a status from that breaker. And if that status doesn't change, that's That's one way you can tell, hey, that operation didn't happen. So I'm gonna be honest, I had to get a little bit fancy with this breaker failure test here. We're going to be using the no current breaker failure as a way to test this function. And I'll show you why it works here. So if you press push button 2 for 1 second, as long as you're in test mode, it'll come through and it'll hit that, that push button 2 LED here. But we're also going to go to sheet 2. You can see that through the rattle.
Yep.
Once we go to sheet 2, we're going to come in and we're going to hit that trip equation. But what we also do is we come down here and that same exact logic variable, it's going to come to this timer. It's got a dropout time of 1 second. So for that second, it can't push this output. So essentially what the test has done is it's a test trip that for 1 second blocks that output. And when we block that output, it doesn't actually trip the breaker. If we don't actually trip the breaker, that status doesn't change. Well, it's test logic to fool us into thinking that that breaker has failed, essentially.
Okay.
This is definitely not anything you'd ever program into an actual relay. This is strictly for us to test because I knew I wasn't going to take the time to set up that test set. I'm having enough time, enough struggle juggling teams and the relays.
So would that light like flash? Would that turn on for like 1 second and then shut off once this like blocks it? Or is it like that?
Go back to the front here. Do you want to repeat that?
Yeah, so like this timer would would it turn on for like 1 second and then like turn off because of this part right here? Or would it
Yeah. So you would come in here. So you press it for 1 full second. That's what's called a rising edge trigger right there. So what that does is it gives it a 1 cycle pulse. Even if you hold your finger down forever, it gives it a 1 cycle pulse. So that 1 cycle pulse comes through. It hits this. So there's no pickup delay. So it can pass through with only 1 cycle. The 60 cycles that we see right there, that's called a dropout.
Yeah.
Which means we gave it a 1 cycle pulse. What it's going to do is stay high for 1 second, then fall back.
Okay. So we prevent it from turning off.
Yeah, because we have that knock gate. For that 1 second, we've got a 1, it's a knock gate, gives you a 0 going into that knock gate. That 0 prevents this from doing what it's supposed to. And the breaker can't open for that full second. And with that, over here, we've got this no current breaker failure. That's got a 20 cycle delay. Usually a breaker should operate at about 3. So we go, it didn't operate after 20, then something's wrong. And then there's actually no logical thread. It's happening organically. Yeah, you can see the trip came in 20 cycles later. This guy is still a 1, right? That breaker is still closed. We never tripped it. Well, we can see the trip came in, it hung out for 20 cycles. This is still a 1. It passes through the breaker failure. So yeah, that's that. We'll try it out here, see how it goes. So what we should see is we press the push button. We should see push button 2 come on. As long as we're in test mode.
Mm-hmm.
And then also we should see the trips come on. I don't think we're going to see that breaker change state. It really depends on the timing there. But it's not going to happen immediately. If it does change state, it'll be a full second later. And then we should come in here. We're going to get a breaker failure initiate. We probably won't even be able to catch it. We'll be able to see that target LED 6 turn on just momentarily. If you really focus on it, I bet you'll see it, but probably going to be looking other places. You probably won't see it. you wanted to look in that SCR I was talking about, you can capture it there.
Okay.
But then the breaker failure will come through and LED 7 should come on. So really what we should see is push button 3 LED coming on, target LED 7 coming on, and the trip LED coming on. So we'll put it in test mode. That's blinking, we're on. It's this push button 2 that should do it right here. Test BF trip. Let's see what happened. Oh, the breaker was open to start. Yeah, there's no point in breaker was already open. Let's close it. Do a target reset. Well, that was done. Okay, let's try it again. Test breaker failure. Okay. So we can see here, we got the LED. It tells us it was a test breaker failure trip. Okay, that's that guy right there. You can see the trip LED was on. We talked about that. And then we can see this BF trip, which is target LED 7. So we can follow that through. Similarly, right, if we want to close that breaker, we'll reset everything. If I turn that guy off, shouldn't do anything. But you didn't. So we can come through and say, right, that worked. We saw that LED come in. We're able to use the target reset to make it go away. Do that reset. Follow that into sheet 2. Okay. We came here. We saw that trip LED come in, so it must have made it here. And then we saw this. This is a situation it's tough to tell what happened just by observing.
Yeah.
You really got to look at that SCR. Well, the SCR that gives you yeah, if I could just get this friggin' thing to communicate. I'd show you. And I did show you guys that first lecture. But you guys probably don't remember that because it's been 2 months and without context, probably not as valuable. But yeah, it's a big list of what has asserted and deasserted. So and it has timestamps. So you can see, for example, PSV 08 came in at 6:05 p.m.
Okay.
And then you can see after that BK1 MTR came in, pretty much at the exact same time. You can see the PSV 02 asserted, same time PC12 asserted, 1 second later, deasserted. And you can use those timestamps to say, okay, this happened and this happened. And rather than just observing through the front of the relay, you can see that order and see, well, this happened first, then this happened, then that happened, then that happened, and that happened. You can actually see those word bits in a list. It'll say assert, which means it turned on, deassert, which means it turned off, and has a timestamp.
Cool. So that'll probably be pretty helpful if we're going to check stuff.
Yeah, that's how you do it. Yeah. So, unfortunately, I am having some comm issues. Yeah. I should have just connected to that other relay. The reason I didn't connect to that one is because we already have
Settings of
I can push the settings easy. Like I can communicate to that one and push the settings. This one actually has the labels, those little pieces of paper. You can see I slipped those up in there. I didn't do it over there, so.
Sorry to tell.
Yeah, that's just why I didn't go over there. But I think
Makes sense.
that first lecture I was over on that relay. Everything was great. I think this one's got a busted COM port. So, yeah, fortunately.
Did you try the front panel serial port?
I don't have a serial.
Okay.
After with me, Brent, Shane.
Yes.
I should. I don't.
No.
I don't go out in the field all very often. You going to Texas last week was more field exposure than I've had in the last year. So
Yeah.
yeah, I tend to get stuck in the office these days. Used to do it
Where
more.
you want to be.
Yeah, I've got a family, so it's nice.
Exactly.
Um, so I think the last part that I have here is the reclosing logic. So what I can do for this reclosing logic, it's another situation I had to get real clever on. So you know how I talked about the swirl? If it gets onto that line, right, you're gonna want to trick for that.
Mhm.
Well, the squirrel burns, it falls to the ground. You want to reclose.
Yeah.
Well, I wanted to find a way to simulate that. So this is again very clever. Probably wouldn't do it like this in real life. But we have a way to check that. So how did I do this again? Maybe we put other sheets. Let's see here. So let's say I come in. You guys can see if you go to sheet 3. We've got our reclosing logic. And if we come in here and we have a trip, that'll do our our reclose initiate. So I got to make sure I've got 79 on. I got my 79 fail. I think that'll drive the reclosing to lockout. Oh, yep, because I turned it fucking. So I gotta turn that off for a second. Or turn it on. Turn the function on. Turn LED off. Unfortunately, a part of this is when you turn that off, it drives reclosing to lockout. We got to wait a second for that LED to drop out because it won't let us do reclosing. That does not drop out. But I'll explain what we're trying to do here. So if we do a reclose initiate, what we can do is put this in test mode. So if we put it in test mode, we can do a test trip. That's going to come through. Going to hit the trip equation. Trip equation is going to go to our reclosing logic and sheet 3. It's going to do a reclose. As long as the reclosing is on, this should have reclosed a number of seconds after. I think we have it set to 5 seconds. I'd have to double check the settings. And then what I can do is actually re-trip it again. We got a second one at 10 seconds and then a third reclose at 15. If we go through that whole reclosing cycle, it'll drive itself to lockout. So I'm pressing a push button to simulate a trip, but let's just imagine it is that squirrel. And we're going to go through a reclosing cycle. So I want to go to test mode. I want to do a test trip. It's going to go from breaker close to breaker open, and then it should slam back in after a period of time. Okay, so see how long this takes. I thought I changed it to 5 seconds to make it faster. I may not have. And then I can actually trip it again. Let's say that squirrel didn't burn, right? I meant to change that to 5 seconds, so we didn't have to. Oh, yeah, I probably have it set to 15. This next one can be even longer. Squirrel time to burn. This one's probably 45. Yeah, this one's probably 45. I meant to change it to 5, 10, 15 to make this quicker. I bet you this one's 60. Yeah. Yeah.
What's the time usually like for like reclosers on lines, I guess?
It depends the situation. I think, in actuality, this 15, 45, and 60 on a distribution circuit is not uncommon. You do want to really give that, whatever it is, time to go away, like if there was something burning.
Yeah.
I would say on a transmission system, the 5 and 10 is a lot more. Yeah. This one is taking forever. Yeah. And then that's all we get. All right, that's it. No more, no more. We gave it 3 chances. Yeah, that's all we're gonna give it. We gave it enough time to know it's probably not a squirrel, probably something permanent. We can, and we can see here, okay, 79 failed. We tried to reclose, it didn't work out. Yeah. You know, we're gonna stay put. Or stay open. So, yeah, that's the reclosing logic. I could, if I had more time, work through the rest of this. We've got a few other things, like I could have checked here. We did have the drive lockout. Rather than doing a regular test trip, we could have done a break and failure trip. That would hit the drive to lockout. So that's the situation. The breaker failed. We don't want to reclose because it's failed, right? So rather than allow us to reclose, it just drives that whole thing to lockout. Rather than going through that whole sequence, we would have just gone straight to 70. Yeah. You also could have gone through it, trying to see, does it work with 79 off? It's not going to work with 79 off. You know, we didn't have time to run through that. So, yeah, we'll disappoint there. I got to mark some of this up. I got to actually change those to 5, 10. Yeah.
And with the lockout prevents like most of the floppings. It's not a breaker, you can't do that stuff, right?
Yeah, usually, if there's a lockout, it'll do a block close. So you can't do that manual close. What it usually requires is if you hit a lockout, it blocks the reclosing, it blocks the manual closing, it blocks the SCADA closing. Someone needs to actually drive to site. They need to go to that lockout, be brave enough to reset it, and then be brave enough to close it in.
Yeah.
So usually if you roll a lockout, there's an investigation, right? You are searching high and low. You usually got thermal guns where you go along the equipment and say, okay, you know, 50 degrees, 50 degrees, 50 degrees, 50 degrees, 120 degrees, let's look there.
Yeah.
Right, you figure out what happened. You know, you remove whatever happened. Once you have done all of your, you know, steps to ensure that whatever caused it, it's gone, then you reset the lockout and then close back.
Yeah, that makes sense.
Yeah, but there's a whole process. If you see a lockout roll,
Just mark it goes in.
yeah. But yeah, it trips everything out and you can't close it out.
Yeah.
So, yeah. So I think that's it for, you know, running through this logic diagram. I definitely apologize for some of the technical issues, just with Teams and email and communications to the relay. Pretty confident it's a busted port on the back, though. I'll have to remember that for next year and use the other 421. I guess, does anyone have any questions? I know we're a little bit over. I know we started a little bit late, so. Kind of using up that time. Has Paul sent any of you guys the homework yet?
Yes.
Yes.
Sounds good. Yeah, we'll have more to the lecture on Thursday. You know, we'll go over the rest of that. Usually I would do this lab portion, that last section. You know, that third part of the sequence. Gonna be honest, Jude was on campus today. She's not on campus on Thursdays. So here I am. Yeah, we'll go through the rest of the lecture on Thursday. That'll give you guys everything that you need for the homework. And I think this time I did explicitly not only put it on the Word document, but specifically told Paul that it'll be a week after Thursday. So what's Thursday? What's today? 25th. So Thursday would be the 27th. So a week after that would be what, April something?
It's marked for the 3rd.
Okay, does that line up with next Thursday? Okay. perfect.
Yep.
All right, I didn't mess up dates. No more spring break to get on that. So. All righty, well, I'm hoping you guys were able to gain something from this over Teams. I know it probably wasn't ideal, probably not, you know, what it would have been in person. If you live more than an hour away, sorry for that. If you do live local, I probably feel less bad, but yeah. So I'll catch up with you guys Thursday, and you know, if anyone has any questions, you know, you can reach out and I'll help out. So.
I actually do have a question just looking at that homework. It does mention an Excel sheet for some
Yes.
views of current.
Yes, Shane, send me a
see.
Teams message about that
Okay.
on my UCI. Yes, I need to get that
Yes.
Excel sheet to you.
Okay.
Yeah.
Sounds good.
Good call. It's pretty much just a time current curve.
Okay.
Yeah, it's an Excel spreadsheet for a time current curve. So.
Awesome.
All righty. Well, sounds good. I'll catch up with you guys later.
Thanks, Leo.
Thanks, Leo.
Thanks.
Sorry if I took up the time to ask questions, but I thought it was really helpful in person. I feel like I picked up a lot of stuff.
Yeah. Hopefully it was pretty cool in person. I know you guys have probably had a class where it's a lot of PowerPoint presentations, and hopefully something like this was better than a PowerPoint presentation.
Yeah, definitely.
Yeah, it's definitely tougher over Teams though, right? I don't know how much they were able to get from my hand, like, you know, going into the frame. Yeah. So, but yeah, this is